Hello everybody. So in today's video, I'm going to be covering a bunch of concepts you learned in 9th grade that you should remember before going to 10th grade. I'm not going to be covering them in detail, I'll just be going over them. Of course, it's impossible to cover everything, but I'll try my best. First thing we need to remember is logarithms. So logarithms is a part of algebra, technically. It's basically a way you just rewrite an exponent. Like let's say 8, correct? Now 8 can be rewritten as 2 to the power of 3. Isn't it? So 2 to the power of 3 is just equal to 8. This is the exponential way of depicting this. But what would be the logarithmic way of depicting this? If you have to express this as a log, you have to say log 2 8 is equal to 3. This is the logarithmic way of writing this. If you were to write this as a log, it's nothing but log 4 16 to the power of 2. So how do you read this? It's log 16 to the base 4 is equal to 2. Now the way I remember this is using a little trick, BAP. BAP stands for base, A stands for answer, and P stands for power. So we're going to apply this BAP rule in this entire chapter, and it'll make your solving very easy. Like let's say, if you have to solve this, 3 to the power of 3 is equal to 27. If you first have log, and then your base is the same base as this number, so it's 3, base answer. So answer is 27, so 27, and then we have power, which is again 3. So this is how you represent this as a log. So base, answer, power. Now let's get to a few sums. If we have log 8 to the base root 2 is equal to x. Now again, let's rewrite this as an exponent. This is the easiest way to solve it. So this would be your base, this would be your answer, and this would be your power, isn't it? So this is a base, so root 2 to the power of x is equal to 8. So root 2 to the power of x, we can just rewrite this as 2 to the power of half x, which is equal to 8. So 2 to the power of x by 2 is equal to, now this 8 can be rewritten as 2 to the power of 3, right? This can be rewritten as 2 to the power of 3 because I'm not changing anything. I'm just making both sides have the same base. Sorry, x by 2 is equal to 3. So therefore the value of x is just 3 times 2, which is 6. So x is equal to 6. If you plug this in, you'll actually see that it's 6. So root 2 to the power of 6 is equal to x, right? Because 2 half into 6, which is just 2 to the power of 3, which is 8. So this is how you solve this. Log x base 4 is equal to 2.8. Base, answer, power. This is simple. Just this one thing you need to remember. Your entire chapter is solved. So base, which is 4, answer 2.5, and power, which is just x. Now this is easy to calculate. You just need to find the, solve this and get your answer basically. Now 2.5, in order to make it easier, I'll express it as a fraction. I'll say that this is 4 to the power of 5 by 2 is equal to x. Now 4 again can be rewritten as 2 to the power of 2 times 5 by 2. This cancels off the form x. So 2 to the power of 5 is just ultimately 32. Log 5x minus 4 minus log x plus 1 is equal to log 4. Now before we get to this, we'll actually look at the laws of logs, because in order to do that sum, you need to look at the logarithmic laws. Log m plus log n to the base a. Now remember, whenever I write something as, if I just write log 7, you automatically assume that the base is 10. Okay, it doesn't, so like if it's not written, it's automatically assumed that the base is 10. Log m to the base a plus log n to the base a is just equal to log mn, right? Quite easy. Whenever it's a plus, it's a multiply, but whenever it's a minus, it's a divide. So if you have log m minus log n, it's ultimately log m divided by n to the base a, right? So let's say you have, for example, log 8 plus log 16. So how do you represent this as a single logarithm? It's just log 8 into 16, which is just log 128 to the base a, right? So this is how you represent it. Easy. And then we have another thing you need to remember. Log m to the power of n is equal to n log n. So this is not your base. Let's say it's log to the base a and then 5 square. We rewrite this as 2 log 5 to the base a. Oh, before that, I need to tell you a few things you need to remember. We have log 10, which is equal to 1. Now, how is log 10 equal to 1? Because whenever I said that whenever they don't mention this, it's always 10 to the base of 10, right? So base, answer, power. 10 to the power of 1 is equal to 10, right? Similarly, if you have log 100, log 100 is 2. Why? Because it's base, answer, power. Correct? Base, answer, power. So 10 to the power of 2 is equal to 100. Log 1000 is equal to 3. Log 10,000 is equal to 4, and so on. Another logarithmic law you need to remember is that log a to the base a is equal to 1. Like, for example, you take 6, okay? Log 6 to the base 6 is equal to 1. So base, answer, power. So 6 to the power of 1 is equal to 6, right? So this is just your log, I would say. Log 5x minus 4 minus log x minus 1 is equal to log 4. So this is just log something minus log something else is equal to log 4, right? So ultimately log m minus log n, as I told you, is log m by n, right? So we can rewrite this as log 5x minus 4 upon x plus 1 is equal to log 4, right? So we can just cancel off the logs and say that 5x minus 4 upon x plus 1 is equal to 4, right? And now in this case, all we need to do is we just have to cross multiply. So it's 5x minus 4 is equal to 4x plus 4, because I cross multiplied it. Now take 4x to the other side. So 5x minus 4x is equal to, take this minus 4 to the other side, becomes plus 4. So 4 plus 4. So ultimately x is just equal to 8. So therefore we have gotten the value of x as 8. So whenever you have to solve for x, you just have to use this rule. It's quite easy. It's just your LHS RHS, right? Now let's come to log 8 minus log 2 divided by log 32. Now this may look easy, but there's a little trick you need to remember. As usual, this is just a log identity, log m minus log n. So it's just log m by n, which is log 8 upon 2, right? So divided by log 32. So this is just log 4 ultimately. And this side we can write as log 32, right? So log 4 divided by log 32. In order to cancel this, I need to first have the same base, right? And can they both have the same base? Yes, because 2 goes in both of them, right? 2 is a root of both of them. So you have log 2 to the power of 2 and you have log 2 to the power of 5. Now here's where you need to use another identity to further simplify this. So log m, the base a, the power of n is just equal to n log m, right? So we can just rewrite this as 2 log 2 upon 5 log 2. Now you can cancel the log 2 with the log 2, and ultimately you're just left with 2 by 5. This is your answer. Very important type of sum you can get. If people from grade 9 are watching this is quite an important sum. Okay, so now we come to the final question from this concept. Express 2 log 3 minus half log 16 plus log 12 as a single logarithm. So I'm just going to rewrite this as log 3 to the power of 2 minus log 16 to the power of half plus log 12. Am I changing anything? I'm not changing anything. Now see what I'm going to do here. Log 3 to the power of 2 is just equal to log 9, right? Minus, now log 16 to the power of half is just equal to root 16. So that's equal to 4. So this is log 4. Plus we have log 12. Now log 9 minus log 4, log m minus log n is equal to log m by n. So we can rewrite this as log 9 by 4, right? Plus log 12. Now we have this in the format of log m plus log n, which is just equal to log mn, right? So we can just say this is log 9 by 4 times 12. 4 goes thrice in 12, so this is just 3 times 9, which is just log 27. This is your answer. So the next concept I'm going to be talking about is midpoint and intercept theorem. Now these two concepts are quite important for higher classes, so I'll just be recapping them in brief. So you all know triangles, right? This is a triangle. Now let's say this is A, this is B, and this is C. Now according to the midpoint theorem, the midpoint of A and C, let's call this K, and the midpoint of B and C, let's call this J, right? So when you join JK together, JK is parallel to AB, right? So JK is parallel to AB, and JK is half of AB. This is the midpoint theorem. Okay, this is the midpoint theorem. So this is a right angle triangle. Now this is A, this is B, and this is C. And we have K, which is the midpoint of A and C, and we have J, which is the midpoint of B and C. Now when you join JK together, JK would be half of AB, right? So basically a line drawn from the midpoint of two sides of a triangle would be half of the side of the triangle. If you have an equilateral triangle like this, if you have an equilateral triangle, this side A, B, C, let's say that this side is 4, this side is 4, and this side is also 4. That means a midpoint, that means a line joining the midpoints of AC and BC would be parallel to AB, and it would be half of AB, which is half of 4, which is basically 2. So the midpoint, the line that joins the midpoint would be 2. So using the midpoint theorem, now we also have another theorem known as the intercept theorem. So according to the intercept theorem, whenever you have 3 lines that are parallel to each other, right? These 3 lines that are parallel to each other, whenever there's a transversal that's drawn through them, this transversal drawn through them, and when this transversal makes equal intercepts, let's say that this is 1 centimeter, let's say that this is also 1 centimeter, right? So whenever there are like equal intercepts made, any other transversal drawn, like for example this transversal, would also make equal intercepts. Now it's not necessary that the equal intercepts are the same length as this. The equal intercept can be 3 centimeters. The point is, it will make equal intercepts, like 3 and 3 and 1 and 1, right? So equal intercepts. Now how do you prove it in short? In order to prove it in short, let's say that these are your midpoints. Okay, so this is A, B, C, D, E, and F. Okay, let's say that this is A, B, C, D, E, and F. Now how do you prove that EF is equal to DE? Because that line, that's not given, right? That's not given. We've been given, the data that we've been provided with is that AB is equal to BC, right? So when AB is equal to BC, what we're going to do in order to prove that EF is equal to ED, we're going to basically construct a diagonal here, and by doing this, we can make this a triangle, right? So ACD is a triangle. Now B, and let's call this, let's say this is K, BK is parallel to CD, that means BK is half of CD. This is just the midpoint theorem, correct? So since this is the midpoint theorem, now according to the midpoint theorem, a line drawn from the midpoint of this side that joins the midpoint of the other side bisects it into 2 sides, right? Basically divides it into 2 sides. So therefore AB is equal to BC, correct? AB is equal to BC, that we know. Now as we can see here, there's another triangle that's formed over here. Now basically what we need to do is we need to prove that this triangle DKE is congruent to ABK, right? After we prove that these two triangles are congruent to each other, then this part that's already equal to this part is going to again be equal to this part. And since this is the midpoint of this particular line, this part will also be equal to this part. So that is basically how you prove your midpoint theorem. It's quite an easy theorem. You may get questions on it in higher classes. So another important concept that you learned in grade 9 is identities. So you learned various kinds of identities and how to apply them, right, in your algebra chapters. So let's just recap a few of them. So we have a square minus b square, which is just equal to a plus b, a minus b. This is a very important identity that you're going to be using even in your trigonometry grouping sums in grade 10. That's why I'm just giving you a recap. Now it is a plus b the whole square and a minus b the whole square. Both of them are the same. It's just that when you have a minus b the whole square, it's a square plus b square minus 2ab. And here we have a square plus b square plus 2ab. These are very important identities that you need to remember. So now let's say you have to calculate the square of 98. When you have to calculate the square of 98, it's a huge number, right? So instead of doing 98 into 98, what you can do is you can rewrite this as 100 minus 2 the whole square, right? So this is just a square plus b square minus 2ab, right? So now you know the identity, you know the square of 100, you know the square of 2. So this is just 100 squared plus 2 squared minus 2 into 100 into 2, right? So 100 squared would just be 10,000 plus 4 minus we have 400, right? So we have 10,000 minus 396. So this would just be 3604, which is the square of 98. Okay, so instead of actually physically solving it, you can use these identities to simplify your sums also, right? Another very interesting identity. So just like you have a plus b the whole square, you also have a plus b the whole cube, right? You have a plus b the whole cube. It is just a cube plus b cube plus 3ab. Now here's where many students mess up. They forget to add the additional a plus b. So don't mess up. Okay, it's quite an easy identity. You need to understand it. Next, I have an identity that you would not have really used this last year, but this year you're going to use it a lot. It is a plus b the whole square minus a minus b the whole square. So this is basically difference of squares. However, instead of actually splitting it, solving it, you can just say 4ab. So this is 4ab. So a plus b the whole square minus a minus b the whole square is just 4ab. And then you have two more identities. You have a cube plus b cube, which is basically equal to a plus b, a square plus b square minus ab. So this I think you would have learned this in factorization, right? And then you have one more identity, which is a cube minus b cube. It's just a minus b, a square plus b square plus ab. These are another two important identities. I think that's very essential for you to remember. Got it? So this is how you solve it. Now let's move on to another very, very important concept that you guys cannot forget. It's simultaneous linear equations. So you may think that simultaneous linear equations isn't important, but you're going to require it a lot. So I mean, you maybe won't need your cross multiplication method and all unless you've been asked to learn it in 10th. So let's take any two simultaneous linear equations. Just to give you an example. X plus 2y plus 9 is equal to 0 and 3x plus 4y plus 17 is equal to 0. So these are two simultaneous linear equations that have been provided to you, right? Now it is your job to actually solve them. Now you can solve them in many ways, right? You can either use you can solve it in two ways. You can use either substitution or elimination. I prefer to use substitution. So let's do it that way. So now first things first, what I'm going to do is I'm going to just take something to the other side is equal to. So if I want to take x plus 2y is equal to negative 9, and I'll say that 3x plus 4y is equal to 17. Let's just say this minus 17, right? Now what am I going to do? I'm going to have something in common, like something that I can cancel out. So now that's 2y and that's 4y, right? But again, that's x and 3x. So I think I should rather multiply this twice to form 4y so that I can cut 4y and 4y together. So I'll multiply the first equation by 2. So this just becomes 2x plus 4y is equal to minus 18 and 3x plus 4y. Now again, as I have done this, so 3x plus 4y is equal to minus 70. Now what you're going to do is whenever you kind of multiply something, you always have to change a sign. So I'm going to change this sign, and this sign, right? So what am I doing ultimately? I'm kind of cancelling this off. So this is minus x, and then this cancels off, is equal to minus 18 plus 17, which is just minus 1. So x is equal to 1, right? X, so the value of x we got is 1. Now what I can do is I can take x and put it in any one of these equations. So now I'm going to take 1 plus 2y is equal to minus 9. 2y is just equal to, if you take 1 to the other side, it's just minus 10, right? Because it's minus 9 minus 1, so it's 10. So y is equal to negative 5. So therefore the value of x we got is 1 and y is equal to negative 5. These concepts are important because sometimes, even in your geometry chapters, they won't just give you direct equations. You're going to have to actually use these equations to solve them. And you have quadratic equations this time as well, right? You have a chapter called quadratic. So even there, you may have to, for certain sums, use this concept of linear equations. That's why I told you this. Of course, I could not leave out trigonometry because in my previous video, we had covered the identities, but I did not tell you anything about the standard angles, the various t ratios that you have, this table. So the reason why it's very important this year is because you have a whole chapter called heights and distances where you're going to apply these, right? Apply these in real life, these identities that you have, these ratios. So I'm just going to tell you how to use them. Okay, I'll not do a full video on height and distances. I'm just recapping the 9th syllabus. So in 9th grade, we use these to calculate like certain, sides and all. Like for example, you've been given this right angle triangle. Okay, you've been given this right angle triangle. And you've just been given this perpendicular. Okay, let's call this A, B, and C. Now this is a perpendicular, AC is a perpendicular, AB is a hypotenuse, BC is the base, right? So AC though is 12. Okay, this side is 12. Now, how do you calculate the other sides? You can use Pythagoras theorem. But what if both the sides are not given? Instead, you've been given, this is 90 degrees, you've been given this theta as say 60 degrees. You've been given the value of this theta as 60 degrees. Then how will you calculate this particularly? How will you calculate the, area of this triangle? Okay, I have a challenge for you. How will you calculate the area? Obviously, this will be in form of root 3 and also we won't actually calculate the area. I'm just saying, okay. So look over here. I'm just telling you how to, like the main concept you need to remember. So if you don't have two sides, but you want all three sides, see, ultimately, how will you calculate the hypotenuse? Hypotenuse is what? A square plus b square is equal to c square, basic Pythagoras theorem. But to use the Pythagoras theorem, you need at least two sides, right? But what if two sides are not given? You use trigonometry, simple, you use the trigonometric ratios to find the other side. So two sides are found. After that, you apply your Pythagoras theorem. So now in this case, you have 60 degrees over here, and you have AC as 12. So basic thing you need to remember is that now, let's say, what do you have to calculate? You want to calculate AB. Let's say you want to calculate the hypotenuse. You want to calculate hypotenuse. Now, what is the ratio between hypotenuse and perpendicular chord? P by H. P by H. In this case, what is P? What is H? P in this case is AC. AC upon AB. AC ka value you have been given as 12, right? 12 by AB. Now 12 by AB, is the sine ratio. But that is equal to sine theta. Now in this theta has been given to you as 60 degrees. So since theta has been given to you as 60 degrees, 12 by AB will just be equal to sine. But sine of what? Sine of 60. So sine 60. This is where the application of standard angles come. So you know that this is sine 60, right? Sine 60. What is the value of sine 60? You should know at the top of your head it's root 3 by 2. Anyways, but over here, I'll show you. This is a table. You have to learn this table, okay? So it's root 3 by 2, which is sine 60. So now 12 by AB is equal to root 3 upon 2. How will you find AB? AB upon 12 is equal to 2 root 3. And finally, you can say AB is just equal to, you can take this to the other side, it will go numerator. So 12 times 2 root 3, which is ultimately what? It is ultimately 24 root 3. So 24 root 3, okay, is what you have to ultimately find. Now, since you have a certain denominator, you have to rationalize it. So into root 3 by root 3. So 24 root 3 divided by 3. Now this 3 though will cut with this. Obviously, how many times will it cut? 8 times. So it's ultimately just 8 root 3. 8 root 3 zeros. Okay, this 8 root 3 though will be your hypotenuse. So now that you know this hypotenuse, this square minus 12 square will be equal to BC square, right? And then to find BC, you have to find the square root of that. That is basically your entire formula. That's what I said in my previous video. To know trigonometry, you should know Pythagoras theorem, because both of them are like homies. They are both connected to each other. To find this one side, you apply the Pythagoras theorem, you need trigonometry, and after you get that side, you can get the other side. Okay, so both of them are incredibly useful. If you're not, you won't always be provided with the side. That's why we use this trigonometry to find the other side of the right angle triangle. Now, another concept that you guys had was factorization. Now just look at this for a second. Oh, this is trigonometry. Where does factorization come in here? What if, how do I solve this? How do I solve this? First of all, let's simplify the denominator. Let's simplify the denominator. We'll copy this as it is. 2 sine theta plus 2 cos theta. Now, cosec inverse theta is just 1 by cosec theta plus 1 by sec theta. Did I change anything? I did not change anything. Now, 2 sine theta plus 2 cos theta upon, now 1 upon cosec theta is just sine theta, right? Sine theta plus 1 by sec theta is just cos theta. I want to say that, oh, let me cancel the sine and sine, cos and cos. Can I do that? No. Why can't I do that? Because this plus is here, this plus is here. The entire mode is ruined. Easily I could have done cut it. But why not? Why can't I cut it? I can cut it, right? Now you'll ask me how. I'll say that you can factorize this 2 out. After you factorize this 2 out, you can easily cut both the numerator and the denominator. That is what we have been doing in all our trigonometry proving sums. That is the significance of factorization. So there's something common. To factorize something out, if you have like two different things, or let's say you have 2 plus 4. You want to factorize something out from this. In order to factorize something out from 2 and 4, there will be something common between 2 and 4, right? This expression, there has to be something common between them. So 2 is obviously common. 2 goes once in 2 and 2 goes twice in 4. So 2 comes out 1 plus 2. Done. It's 2 into 3, which is how much? 6. Similarly, this also adds to 6, right? So when you're factorizing something out, there's no difference in the answer. Okay, similarly here. Now here, there's something common between here, this and something common between this. What is common? 2 is common. So I factorize 2 out. Sine theta plus cos theta. Sine theta plus cos theta. Now, who is stopping me? Now I can just cut this. Done. Answer is ultimately 2. This is why factorization is so incredibly important. And this is not the only way to do factorization. Huh? Factorization basically can also be done by grouping. Like let's say you have this thing, this plus, minus. Now, this goes over here. Something that is there in common between the first term, fourth term, and there's something common between the second term and the third term. So you group these two together, factorize something out. That is called grouping. I don't have examples for you right now, but you understand my point, right? And then there's also something called splitting the middle term. Like let's say you have a quadratic. Okay, you have a quadratic. You have let's say x plus y plus k, which is a constant. So you have a quadratic over here. Ultimately, what you need to do, you need to split this middle term, which is this middle term should ultimately sum up to this and add up to that. Okay, I don't know how to explain it right now, but yeah. And then the thing is, I'm not going in detail with factorization because you have factorization this year, and you also have quadratic equations. You have a whole chapter, plus you have applications of quadratic. So that's why I'm not doing this in detail. Otherwise, I would have definitely done a full explanation for you guys. But this is how you ultimately factorize quadratics, right? Basically, what is quadratic? Like a trinomial, basically, a trinomial, right? You also have a few more things. First of all, you have sum of cubes and difference of cubes, right? Sum of cubes and difference of cubes. If you have a cube plus b cube, this is ultimately what? A plus b, a square plus b square minus ab. This is your identity. Similarly, you have a cube minus b cube. This will be what? A minus b, then a square plus b square plus ab. These are your two identities. You cannot forget these, okay? These help. So you're going to like apply these when you use factorization. And then you also have difference of squares. A square minus b square, which I just told you. A plus b, a minus b. Now, if you get like an a square minus b square, you always expand it into this, right? If you get a cube minus b cube, you expand it into this. You get a cube plus b cube, you expand it into this. Okay, how do you get that? Basically, when you get an expression, you factorize something out, take out something in common. When you take out something in common, that will take the form of a square, most likely. And then when you factorize this out, you expand that, okay, and then most likely you'll again get a difference of squares, and then you factorize that further. All that you do, and ultimately you get a long answer. Okay, that's why factorization are 3 to 4 marks, right? Because there's something. Now, what if I told you there was something like a square plus b square? This format. You've just been given a format. Like, how do you factorize a square plus b square? There's nothing in common. But that's what you think, right? There's nothing in common, that's what you think. Now, you can actually factorize it because you guys know the identity a plus b the whole square. A plus b the whole square is ultimately a square plus b square plus 2ab. This is basic, this is your basic identity. Everybody knows this, right? A square plus b square plus 2ab. Now, out of that, we've already been given a square plus b square. A square plus b square, this has already been given. Now, what if I want to factorize it? Then what will I do? Add 2 plus 2ab minus 2ab. Am I changing anything? No, I'm just adding this, minusing this, right? I'm literally not changing anything. So, ultimately, what am I doing? I can just make this a plus b the whole square minus 2ab. Most likely this 2ab will be in the format of a square, so it will be difference of squares, factorize it further. So this will be for 2-3 marks. Got it? This is how questions come in your paper. So you just have to, like, factorization is kind of like a puzzle, okay? You just have 3 different things. You have the difference of squares, difference of cubes, sum of cubes, grouping, general factorization, sum and product, that's it. That's literally it. That's just 6 different ways on how you factorize it, and that's it. To rationalize numbers, right? That's another concept you guys had. Like if you have 1 root 3, how do you rationalize it? If I multiply this by root 3, so it's just root 3 upon which this is how you rationalize it, because we don't want a third in the denominator. Anytime you get a third, especially in your trigonometry, height and distances, whenever you get a third in the denominator, always rationalize it. Okay, even if they don't say rationalize it, rationalize it. If it's a 1 marker, then no one's asking you to rationalize. But if it's a proper 4 marker height and distance question, 5 marker question, then obviously you have to rationalize it. Okay, and then root 3, though everybody knows 1.73, right? All this you guys know. Yeah. Now we had another really important chapter in grade 9. It was called mensuration, that included three concepts. You had circles, you had cubes, cuboids, and then you also had your triangles, right? So let's do a quick recap of them. We just have to know the formulas, areas, volumes. That's kind of what I'm going to do now. Okay, now first thing you need to remember about a circle is that this is what a circle looks like. This is its midpoint, right? This is the radius of the circle, and this is the diameter of a circle. So first thing we need to remember is that radius is equal to diameter by 2. Okay, so the radius is always half of the diameter, so we can just say 2d is equal to 4r, right? This is what you need to remember. Next we come to the area and perimeter of a circle. Now, what is a perimeter of a circle? When you talk about the circle, we don't use the word perimeter, we use circumference. So in order to measure the circumference of a circle, we use the formula 2 pi r. Now, pi can either be 3.14, but again, the numbers are never ending, or what I like to do is I like to use it in the form of fraction, 22 by 7. So whatever's been given in your paper, use that as a value of pi, because this year you'll have a cone and you'll have cylinder. So that is just going to be pi r square h, right? So again, you can use it either as 22 by 7 or 3.14, but it is specified, it use what they've specified. So this is the formula for circumference of a circle, and then when you have the area of a circle, it's just pi r square, right? So like, let's say the radius. Okay, so let's say they give you the diameter of a circle. This is a circle. They give you the diameter of the circle as 14, and you have to calculate its area. So radius would just be diameter by 2, so 7, right? So how do you calculate this area of the circle? Pi r square. So 22 by 7 into 7 into 7. So 1 7 gets cancelled, so it's just 22 into 7, which is 14. 7 2s are 14 plus 1, 154. So 154, and whenever you calculate area, it's always meter square. So this is how you find the area of a circle. Okay. These are just some basic things that you have of a circle. Semicircle. Now we come to the semicircle. What is a semicircle basically? This is a circle and this is a semicircle, right? Sorry, a half of a circle is a semicircle. This part is a semicircle. So if we want to calculate the area of a semicircle, it's just pi r square by 2, right? So it's just half pi r square. This is the formula to calculate the area of a semicircle, right? Now we need to also remember the area to calculate the perimeter of a semicircle, not the area of a semicircle. The perimeter of a semicircle would just be pi r plus 2r. This is how you calculate the perimeter of a semicircle. Got it? Excuse my drawing. This is a rectangle or something. Or like, let's say they give you something like this. Okay, they gave you a circle, and then they gave you 1/4 of it. They gave you this part of the circle, right? And then they told you to find the area of this part or something, right? And then they attach another shape. So what you need to do is basically you need to find the area of the circle and then minus the area of the other shape within the circle, inscribed within the circle. Or what they do is they give you a playground, right? This is a rectangle, and there are two semicircles over here, and you have to find the circumference of this by doing many things and all, right? So this is ultimately what you learned last year. This year we won't have circles per se. We'll have more of cylinder and all, right? We'll have volume and surface area. There's just one mensuration chapter, but I just thought it would be useful for you to remember these formulas. Now, volume and surface area, you are definitely going to be needing these formulas again. So we have, first of all, we have the cuboid, right? Now, in a cuboid, we need to remember the different things that's there. So when you look at a rectangle, a cuboid is basically a 3D shape of a rectangle. Correct? This is your rectangle. This is your rectangle. So like, let's say this cuboid is a room. This cuboid is my room right now. If I have to measure the area of the floor, if I have to measure the area of the floor, what am I going to do? I'm just going to take the area of the rectangle, right? Because the floor is the area of the rectangle. A floor is a rectangle shape, right? But if you want to take, let's say, the area of the walls, then I'm going to take something known as LSA, lateral surface area. If I want the area of the entire room, including the floor, walls, everything, all parts of the room, it's going to be total surface area. So there are four things you need to remember under a circle. First of all, you need to remember the flooring, which is just the area of a rectangle. You need to remember total surface area, lateral surface area, and you also need to remember one more thing. You need to remember the diagonal of a cuboid, right? And other than that, you also have to remember the volume of cuboid. So let's look at the formulas. Cuboid is now, okay, first of all, let's look at a cuboid over here. So this is your cuboid, right? So this would be your length, this would be your breadth, and this would be your height. So in a rectangle, that's just a length and breadth, right? Here we have a height as well. So to calculate volume, it's going to be length into breadth into height, and it's always measured in meter cube. Okay, this is how you cubic meter basically. So whenever they put the word cubic meter in the sum and they don't say volume, just know it's volume. Okay, and then we have total surface area. To calculate total surface area, it's just 2 into LB plus BH plus LH. This is the formula in order to calculate total surface area. And lateral surface area, or the four walls, I would say, is just 2 L plus B into H. This is the formula to calculate lateral surface area. Now, other than that, there's one more thing you need to remember, that the diagonal, right? The diagonal of a cuboid. The diagonal is also called the longest rod. Now, let's say I take a cuboidal tiffin box, okay, and I want to put a long, like, let's say I want to put like a really long spoon inside. I'm just curious, I want to see how, like, the maximum length that can fit in that box, right? So that would be the longest side, which would be the diagonal. So the diagonal is basically the longest side. If you want to take a rod, let's say that this is a room, right? This is your room, which is cuboidal in shape, and I want to see which what is the longest rod that can fit into this room. Of course, if I take a rod in this position, it won't accommodate the entire space, right? It won't be the longest possible rod. How can I place the rod in a way that it can accommodate the maximum amount of space? When I place it diagonally, right? That's why it's called a diagonal. So from this area to this area is just a diagonal. Okay, so that is a diagonal. Got it? The diagonal now we represent it with the formula. plus b square plus h square. So when you get your dimensions, length, breadth, and height, you've gotten everything else. You don't really need to worry about anything. Okay, this is a very easy chapter. You just have to be a little, cautious when you read the questions because you may tend to get confused. And then you have your cube. Your cube is also very similar to cuboid. It's just all sides are equal, right? So in a cube, there's just a, right? There's all sides are equal, so it's a. So there's no length, breadth, height. Everything is just a. So volume would be a cube. If you have total surface area, you have lateral surface area. If you have total surface area, you have lateral surface area. Total surface area is just 6. Total surface area is just 6a square. Lateral surface area is 4a square because you're minusing two sides, right? And then if you want to look at the diagonal of cube, it's just a root 3. And what is the value of root 3? The value of root 3 is 1.73, and the value of root 2 is 1.414. Got it? It's 1.732. So this is your volume and surface area. That's done. Now we had one more chapter based on triangles. I'm just going to tell you that in short. So this is a right angle triangle, right? How do you calculate the area of a right angle triangle? It's the same as any ordinary triangle. It's just half into base into height. The actual formula for calculating the area of a triangle is just half into base into height. By default, it's half into base into height. Of course, there are other types of triangles and all that are there, but by default, it's half into base into height, right? So like, let's say I've gotten this side and I've gotten this side, and I have to do something using Pythagoras theorem. I've calculated this side, and now I have to find the total area of this triangle. So it's just half into base into height. So have you ever wondered why is the formula half into base into height? Like, why is it half into base into height? The reason it's half into base into height is because it's just half of a rectangle. Okay, it's just half of a rectangle. So if I draw this, I complete this, is basically a rectangle only, right? If I take this fork and if I divide it like this, it's just a right angle triangle. But ultimately, it's a part of the rectangle only, right? So it's just half of the area of the rectangle. So in an equilateral triangle, what we need to remember is that all sides are equal, and it has a very special formula. So root 3 by 4a square would be the area of the equilateral triangle. So this is an isosceles triangle. So in an isosceles triangle, this side is always equal to this side, right? And then there's a base. So how do you find the area of it? It's just 1 by 4b into root of 4a square minus b square. 4a square minus b square. This is a formula to calculate the area of the area of an isosceles triangle. That is also one more thing you need to remember, is that when you have a triangle like this, right? How do you calculate the area? How do you calculate the area? It's always half into base into height, right? But what if they've not given you the height? What if they've not given you this height? They've just given you these three sides. They've given you A, B, and C. Whenever they've given you A, B, and C, and they've not given you the height, you've just been given the base. Okay, but that doesn't help. So in that case, what you're going to do, you're going to use something known as a Heron's formula. So according to the Heron's formula, this is how you can find the area. So it's root of S minus A, S minus B, S minus C. Now what does S stand for? S stands for semi-perimeter. If you don't know what perimeter is, it's basically the sum of all sides. So A plus B plus C divided by 2 is what S is. Okay, so that's semi-perimeter, and that's semi-perimeter minus root of semi-perimeter into semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C. This is the Heron's formula. Very important formula, comes always. You need to remember is the diagonal of a rectangle, although I don't think that's that important in grade 10. Just know for your reference, it's just root L square plus B square. Okay, this is just comes sometimes in your exam. So length square plus breadth square. And what is the general area of formula? L into B. Okay, that's it. And then if you want to find cross section of any volume, right? When you have a cuboid, you want to find the cross section. That's just L into B. That's it. Okay, just need to remember that much. Now we'll just get to one last topic. That is your statistics part. So statistics, I'll just skim through it. It's not much, and I think that's all you need to really remember from 9th. Other than that, yeah, so these things what I've told you right now are not going to be repeated in 9th. Okay, as in you won't have chapters. That's the reason I've done it. Your cyclic properties, chord properties, arc properties, I'm pretty sure they'll be repeated again in 10th. That's why I've not made a video on it. Okay, now we move on to statistics. There's nothing much in statistics. Statistics also, I think it's just the same. It'll be repeated again this year. That's why I'm not going to do it in detail at all. I'm just going to tell you the basics. So we have something known as mean, right? We have something known as mean. Whenever we've been given certain data, let's say we've been given a series of numbers, X, Y, Z, all that, we just have to add them up and divide it, just finding the average. Whenever you're finding the mean of a series of numbers, you're just finding the average. So X plus Y plus Z divided by 3 would be the mean. So it is a sum of observations divided by the number of observations. That's the formula to calculate mean, right? Now if you want to calculate mean in a tabular form, there are 3 methods. Okay, over here I just have 2 in front of you. First we have the direct method. Direct method means you have to make 2 columns. One is your Xi, one is your Fi. Fi is like the frequency or something, right? It's like the number, and Xi is just like what you've written. So Fi, Xi over here, and then you just know the formula to calculate mean. Mean is equal to sigma Fi Xi divided by sigma Fi. Okay, now to all the brain rot people that are watching, sigma means sum of. Okay, in your paper don't write sigma boy and come. So mean is sigma Fi Xi divided by sigma Fi. Okay, that is when you take your Fi Xi and you take your Fi, basically the sum of this would be here, sum of this would be here, this divided by that would just be your mean. Understand? It's very easy. And then coming to your assume mean method, when you want to take an assume mean, when you have like huge numbers like this, you obviously can't sit and add, multiply everything. So you're going to assume a certain mean. Okay, you're going to take mean, like over here you've been given this data. Over here you want to take the mean as, let's say, 150, right? You take the mean as 150. So this is the mean of this particular series, and this is the frequency that's been given to you. And then from the class mark, okay, the Xi, what you've been given. So this is Fi and this is Xi, right? So Xi, what you've been given is that what you're supposed to do, you're going to have to minus the assumed mean, right? So like, let's say this is 110, so it's just going to be 110 minus 150, because we've taken 150 as the assumed mean, right? So since this is the assumed mean, 150, 110 minus 150, which is minus 40 over here. And then you're just supposed to multiply your fi and xi, so for minus 40 into 10, and you're supposed to multiply minus 20 and 20. All that you're just supposed to multiply from your fi xi, right? So this is again sigma fi xi divided by sigma fi. But there's an additional step. Since you've taken 150 as the assumed mean, you have to also add 150. So the formula for this would be sigma fi xi divided by sigma fi plus a. A stands for your assumed mean. This is how you find mean using the assumed mean method. And when you talk about your median is just your middlemost term. So you've been given a bunch of terms in a series, and out of all of them, you're going to take a middlemost term. Next topic is what is probability. We'll just wrap up with that. Probability is what you're going to study this time. Okay, I'll maybe make a video on it as well. Probability, you just need to remember one formula. It's just the number of observations upon total observations. Okay, number of observations divided by total observations. So like, let's say if you want to roll a dice, right? If you want to roll a dice, what are you going to say? What is the probability of getting an even number? Now, first of all, what are the outcomes on a dice? You have 1, 2, 3, 4, 5, 6. More than this you can't get, right? So what are the even numbers over here? The even numbers, if you can see, you have 2, which is even, you have 4, which is 6. So out of 6 outcomes, 3 are even. So it's 3 by 6. And if you cancel this off, it's half. So 1 by 2 is a probability of getting an even number. Same with an odd number. It's 3 by 2, 6 again, right? Which is 1 by 2 because it's the odd number, right? And then you also have to remember like something, as in there's also something called absolute event and impossible event, right? Absolute event is always 1. It's always 1. Like, let's say, what is the probability if I want to roll a dice? What is the probability of me getting a whole number? Whole numbers, so you know by default 1, 2, all of them are whole numbers, right? So that's just 6 upon 6, which is 1. That's a sure event or an absolute event. But an impossible event is something which is 0. Like, let's say, what is the probability of me getting full marks in any of my exams? 0. Okay, so that's an example of, okay, don't write that in your exam. Okay, this might actually come for theory in your MCQs and all, maybe a certain reasoning type, what an absolute event is, and especially in 10th grade because you're going to have probability this year. Okay, now let's say there's a bowl over here. Okay, there's a bowl full of, and this is your class elections or something. So it's filled with chips, right? Filled with chips. Now, what is the probability of you? And there are some 14 girls in the class. Okay, there are 14 girls in the class. What is the probability of you to get a boy? Okay, pick up a boy. So as I said, there are 30 people in the class. So it's 30 minus 14, which is just 16. So 16 out of 30. Now, if you want to cancel this further, what are you going to say? This is 8 upon 15, right? 8 upon 15. So 8 upon 15 is the probability of picking up. If you want to calculate this in terms of percentage, you're going to have to do into 100, right? Into 100. So this is ultimately this is 3 into 20, right? 3 into 20. And then 8 2s are 140 upon 3, 140 upon 3. So you just calculate it as a percentage and find it, right? Whenever you take probability, it's always just as a fraction. It's just either 2 by 3 or 4 by 5. But again, if it's 4 by 6, you have to simplify it. Okay, you have to make it 2 by 3 because then your teacher won't give you marks if it's not simplified. So these are all the concepts you've learned in grade 9. Okay, there are more. You have had your, okay, let's take a look at all of them once again. I have my book here, which I used in 9. We have our compound interest, but the thing with compound interest is that we're not going to be using it ever again. We'll have 3 new commercial mathematics chapters. We have GST, we have shares and dividends, and we have banking, which is a lot different from what we learned last year. Algebra, I think I covered mostly everything. Factorization also, we have a chapter this year also, right? Logarithms I covered, indices I covered basic expansions, linear equations, and then you have your midpoint intercept. Pythagoras also, I think all of us know what Pythagoras theorem is. Quadrilaterals also, quadrilateral is just a 4-shaped, is it just a shape with 4 sides? This is a quadrilateral. A rectangle is technically a quadrilateral, right? Now, quadrilateral has certain properties. This is one angle, this is another angle, this is another angle. All of them add up to 360 degrees. And then based on that, you have certain things like vertically opposite, you have adjacent, and you have interior alternate. And then using that, you have to prove various things using congruency. Just the same thing. Okay, that's an easy chapter. And then, of course, you have chord properties, arc properties of the circle, which I covered, which I don't know if I should cover or not. And then lastly, we have trigonometry, which again, I made a video on that, right? I explained the basics of trigonometry, and I'll very soon upload another video where I've done a few trigonometry related sums. So that's all for today. I hope you've understood the concepts in this video, right? They're quite important when you go for 10th grade and higher classes. You're going to use the same concepts you studied in grade 8, grade 9. And yeah, so that's all for today. Thank you so much for watching today's video. Let's meet again in the next video.